All right, so the way that this comparison works is on the top of these lines, I'm going to write the things that are linear and what's going on with a line. This is what we've been studying all like last semester and even when we did systems. And then below it, we're going to write the kind of corresponding thing and how it compares to when it's exponential. So linear line, the equation that we wrote for that, does anyone remember what it is? Y equals, ooh, I heard somebody, mx plus b. Okay. So down here below is everything that is exponential. So below here I'm going to write this is exponential. So my comparison here, this is just kind of a fill in the blank deal, okay? This top row talks about the equation, okay? So, and what this means is an equation for a line, the most common one, is y equals mx plus b. But an equation for something exponential is y equals a times b to the x. So it's just comparing the equations. Okay. So let's now move on to the next thing, which is the initial condition. So this is about the equation. Initial condition. Can somebody tell me, so this is, we're thinking about y-intercept or starting value. This one is a line. Can somebody tell me when we are dealing with lines, what of those letters is the initial condition? Ooh. It is B. Remember the y-intercept was B. So that was our y-intercept. I'm going to put under here y-intercept too, because our initial condition and the y-intercept are the same thing. So that's for our line equation. We started our lines at B. Do you remember that? We put B on the y-axis and then we did rise over run? Okay. When we're dealing with our exponential equation, remember that's A times B to the x. I'll write that down. It was different. We started at A, so be careful of that. The B's in the different equations mean different things. And you were telling me that you got that in the opener, right? That number, you were putting that starting value in that first spot there for A. Okay. When we're doing lines, we are adding M, or the slope, adding is the key word here, onto our equation. This is wrong. What should this be? This is a line, right? Would you cross that out? That should be y equals mx plus b. Can somebody tell me what do we do when it's exponential? We don't add anymore. Oh, we multiply. And we multiply by B. This was our multiplier. The equation that goes with that is y equals a times b to the x. Okay. Let's take a look at this one. Let's do our graphs and then I'm going to kind of put some other things down there. What does, when you have y equals 3x plus 7, that's growing. How can I tell it's growing? Not just that. The slope is positive. Do you remember how when slopes were positive, we went up and over? Okay. Would you just draw a line, a picture of a line that's growing? What would that look like? Can you draw it in the air for me a second? It's straight, it's not curved, and it's going up from left to right, so like that. Okay, so what we've been studying is also growth and decay. So can somebody tell me how you know this one's growing? What number in there tells you it's growing? Cameron? The 2, the times 2. Good, very good. What's an exponential growth look like? I'm seeing somebody's drawing it in the air. What's different about this than when we're doing when we were drawing graphs, guys? What's the difference?
Oh.
It's curved and it doesn't go below the 0. Yeah, all right. So would you draw a curve going up like that? All right. Now we're moving on to a decreasing graph. How can you tell y equals negative 3x plus 7 is decreasing? Negative slope. Okay, so we start at our 7, our y-intercept, and this negative slope means we go down 3 over 1. That's how we graph those. If it's constant or a line, we want to make sure it's straight and it's going down from left to right. Okay, how about exponential decrease? It's curved and same deal where it does not go below 0. So we want to draw a curve, does not go below 0, something like that. Okay, so let's just summarize then. What does constant increase look like? A line sloping up. What is the equation? Y equals, I don't know, give me an example of something that would be going up. 5x minus 1. The minus 1 doesn't matter. I'm going to just put an arrow by the 5. That's why it's increasing, because it's positive. All right, constant decrease. Line sloping down. Would somebody give me an equation for a line that's decreased? Just shout it out if you think you got it. Oh, should we just do the same one? Y equals negative 5x minus 1. What does that minus 1 mean again? That's just the y-intercept. That's just where it starts. It doesn't have anything to do with graphing up or down. All right, growth looks like this. Somebody give me an equation that would be exponential growth.
3.
Put it in the form y equals a times b to the x.
3 times 2.
Well,
Do
a different one since I gave you that one already. Make up
3 times 4. No, 4 times 17x. Doesn't matter, just random numbers.
Well, one part matters. What's the part that matters that it's growing?
4.
Not the 4, that's the y-intercept.
17.
The 7. 7 is a number that I'm multiplying and it's bigger by 1. What if I wanted to divide by 7? What would I make that? Not divided by 7. We'd make it, anyone know? 1 over 7. So if I wanted to make the same one that was decay, it would be 1 over, not 1 minus, 1 over 7 to the x. That would be like dividing by 7 over and over again. And we said this looks like this. Okay. Here's another, one thing that we're going to notice in this class, here's why we say this class. You know how I was saying this never goes below 0, right? Because really what we're using exponential growth and decay for is real situations. And if I have an initial condition, it's always going to be positive. And after I multiply by something or divide by something, it's still always going to be positive. So for this class, I'm going to write here, it's always greater than 0. So for instance, like in a table of values sometimes, that kind of can help you figure out, hey, it might eliminate if something's exponential. Okay. Whereas these ones, if you have a line, it's going to continue to go down eventually. It's going to get to be negative, whether it's going decreasing or increasing. Okay. How are we doing?